This is our lesson over section 5.2, synthetic division, and an introduction to the beginning of section 5.3. So as you look at my PowerPoint, we've already done long division, and we know one way to divide a polynomial by another polynomial is by using long division. But a second way of dividing two polynomials is to use synthetic division. The problem with synthetic division is it's limited to where we're dividing a polynomial by a binomial, two terms that are of the form x minus r. Now, it doesn't mean it has to be the operation of subtraction, it just has to be a binomial of that form, x plus or minus some number. And the nice thing about it is it's a little simpler of a process than long division because it does not involve all the variables and their powers. So we're going to compare. So I am going to move this up, and I have a problem that we're going to do using long division first. So we're going to take the quantity 3x to the third minus 2x squared plus 2x minus 5 and divide it by the quantity x minus 2. So if you recall from class the other day, you start with the divisor, the first term, x, and you see how many times it can go into the 3x cubed. Of course, x times 3x squared would be 3x cubed, and now we multiply 3x squared by the divisor. That gives us 3x cubed minus 6x squared. And you may recall in class, what I told you to do instead of subtracting is to add the opposite. My experience is students make fewer errors, and I don't think there's a single math teacher in our department that doesn't have you change the signs to their opposite, and then you add. So obviously the first terms cancel. A negative 2x squared plus 6x squared would be 4x squared. And then we're going to bring down the next term since our divisor has two terms. Now we're going to repeat the process, and we're going to look and say, how many times does x go into 4x squared, what we just had here? So x times a positive 4x would give us 4x squared. And then we multiply it times the negative 2, and that's negative 8x. And then we're going to change our signs to their opposites so we can add. And of course, the 4x squareds cancel, but now we have 10x, and we're going to bring down the minus 5. So now we're going to repeat the process, but we're going to start here, and we're going to say x in the divisor times what is 10x, and that would be a positive 10. And then taking the positive 10 times the divisor is 10x minus 20. And then I add the opposite, so I change my signs, and now I can cancel my 10x's, and negative 5 plus 20 is 15. And when I have that remainder, I'm going to write plus my remainder of 15 over my divisor of x minus 2. And so that would be my answer. What you see right here, 3x squared plus 4x plus 10 plus 15 over x minus 2. The good news is that's not the only way we can divide. This is where synthetic division comes into play. So in synthetic division, we write a half box, And you might recall up in our notes that we use this x minus r, and we need to know the value of r. Well, in our problem, r would be the value of positive 2 right here. That would be r. And it's positive 2 because the operation is subtraction, and that's what we want. So I'm going to put a positive 2 in my half box, and then I'm going to take my coefficients in the problem and write them out, leaving a little space in between. If I ever am missing a power of the variable, I do want to put a ghost term of 0, but that's not an issue here. I have degree 3, degree 2, degree 1, and the constant term, which is degree 0. And when you do synthetic division, you always drop down the leading coefficient of 3, and then you draw the vertical line on the last column, because in that last column, that's where our remainder is going to be. So the process of doing synthetic division here, what we want to do is we want to start by multiplying the value in the half box with our first, can't get this to stay on. There we go. 2 times 3 is 6, and I'm going to write that under the second coefficient. And then I add, and negative 2 plus 6 is 4. And now I repeat the process. I take the 2 in the half box times the 4 I just got, that's 8. And then I add that column, and 2 plus 8 is 10. And then I multiply one more time. 2 times the 10 is 20. And when I add, I get a remainder of 15. Now, what I want you to do is notice how these numbers correspond to the numbers up in my answer that I got when I did long division. So they're the same because they give us our answer, and we have to remember, we have to remember that the exponent in the original problem, that exponent is going to decrease by 1, and we are going to interpret this as 3x squared, 1 degree less than what we had when we started, plus 4x plus 10. The degrees just decrease by 1 each column, and then the 15 is our remainder. And we do not put that over the 2 in the half box. We actually put it over the divisor, which is the x minus 2. So now we actually have the exact same answer that we got when we did long division. And that's the beauty of it. We can divide both long division and synthetic, but for obvious reasons, synthetic is a little cleaner, but it is limited to being able to be used only when you're dividing by something of the form x minus r. So let's try a second problem. This right here, what we're dividing by, is of the form x minus r. We do have to understand, to be plus 4, it would have started as x minus a negative 4. So r is actually a negative 4. It's the opposite of the operation. So in my half box, I want to put negative 4. And then you're going to notice I have a 2 for my first coefficient. That's my degree 3 coefficient. But do you see that we don't have a degree 2 term? We jump from 2x cubed to positive 6x to the first. So I need to put that ghost term 0 for my coefficient of my squared term. Then I continue with the 6 for the first degree term, and then my constant term. Draw my line, drop my leading coefficient below the line, draw my vertical line for my remainder. So now I'm going to divide or do the synthetic division. And so, of course, I'm going to multiply the half box value by the leading coefficient. -4 times 2 is -8. When I add, that's -8. -4 times -8 is 32. When I add, that's 38. -4 times 38 is -152. How convenient. So when we add, our remainder is 0. So interpreting our answer, this would be 2x squared, 1 degree less, remember, than the original degree of 3 up here, then minus 8x plus 38. Let's try one more. In this problem, we've got a problem with our divisor because it's obviously not of the form x minus r. So what we're going to have to do is divide our divisor by 2 so that we get it in the form x minus r, or in this case, y minus r. And if we divide the divisor by 2 to get the right form, we have to divide the dividend by 2. And when we divide that by 2, that would mean our problem was 2y to the 4th minus 5 halves y squared plus y plus 2. And so setting up the problem, you can see why I have positive 1/2 for r. And then my coefficients, notice I have 2, but it's really easy to overlook putting a 0 for the degree 3 term. Then we have -5 halves, positive 1, and positive 2. So now let's do synthetic division. 1/2 times 2 is 1, and when I add, I get 1. 1/2 times 1 is 1/2. When I add, that's -4 halves, or -2. Half of -2 is -1. When I add, that's 0, and 1/2 times 0 gives me a remainder of 2. So interpreting my result, I get 2y to 1 degree less than I started with, which is y cubed plus y squared minus 2y. I don't have a constant term, so I then can say plus 2, the remainder, over the divisor, which our half box value, we used y minus 1/2. The problem with that is we have a complex fraction, a fraction in which there are fractions in the numerator and denominator. So what I'm going to do is multiply the denominator by 2, which means I get to multiply the numerator by 2. So my final answer here will be 2y cubed plus y squared minus 2y plus 4 over 2y minus 1. Good. I hope that helped. There are some additional examples because you're going to notice I did the odd examples from my notes. The rest of my notes are on Canvas. And now I want to take you to the start of section 5.3. There is a blank handout on Canvas. But what I'd like you to understand is something about polynomials being in standard form. And when you have it in standard form, which means it's in descending order of exponents, largest to smallest, we should be able to identify what is called the degree of the polynomial. It will be the largest degree of all its terms. And then the leading coefficient would be the coefficient of that first term, again, assuming it's been written in standard form. So let's take a look here before we do some examples of some common names that I want you to learn. When the degree is 0, we call it a constant function. That happens when you have something like 5x to the 0, because x to the 0 is really 1. That really means 5x to the 0 is 5. Something that's linear, negative 2x plus 3, that would be linear. Degree is 1, that implied exponent. Quadratic could be any quadratic. You could have 1/5 x squared plus 2x minus 5. Cubic means we'd have something of the form 1/2 x cubed minus 1. Quadratic, of course, means the degree is 4, and quintic means the degree is 5. So let's see how we put this together here. I want you to focus your attention on the first 6 problems right in here. It says state the degree and leading coefficient of each polynomial in one variable. Meaning you can't have more than one variable in the expression or it doesn't meet that criteria. So if we look at a plus 8 for number 1, it doesn't matter what the unknown is. It could have been x plus 8. But the bottom line is it is polynomial. And that means that we can identify the degree as 1. That's the degree of the largest term, and the leading coefficient, which is 1. And we would refer to this as a linear function. Number 2, we get to multiply. So if I do FOIL, I get 8x cubed, and then I get plus 6x minus 4x squared, and then I get minus 3. Of course, it's not in standard form until I reverse the order of the 2 middle terms. So standard form should look like this: 8x cubed minus 4x squared plus 6x minus 3. So the degree here is 3. That's the largest exponent. And the leading coefficient is positive 8. And because the degree is 3, we would call this a cubic function. Number 5, it's already in standard form. It is a polynomial in one variable. Its degree is 5. And its leading coefficient is negative 5. And as far as what it would be called, it looks like it is a quintic, degree 5 there. Yep. And so I can call that a quintic. Number 4. Looks like a polynomial in one variable. It's in reverse order, so to put it in standard form, you'd start on the right end and go to the left end. So you would say 7y to the 6th minus y to the 5th plus 5y squared minus 3y plus 18. That means the degree is 6. And the leading coefficient 7. And we already talked about reversing the order for standard form. Number 5, easy. The answer is no. It is not a polynomial in one variable because we have a product of u and t. So it contains 2 variables and therefore is not a polynomial in one variable. In number 2, the key thing that's wrong is 1 over r squared. Remember, that has to be plus r raised to the negative second. And to be a polynomial, the exponents cannot be negative. So the answer here on 6 is no as well. So good. That is all for our lesson. The assignment will be in Canvas. We'll actually finish this green worksheet. We won't do every problem, but we'll do a sample of the problems there for next Monday. Have a great day.